Hello everyone. Today, we're going to dive into an interesting and efficient sorting algorithm called the cycle sort. This algorithm is particularly useful when you need to sort an array of elements where each element has a unique value within a specific range. So, what is cycle sort? Cycle sort is an in-place sorting algorithm that is especially efficient for sorting arrays, where the elements are integers in a specific range. The key idea behind cycle sort is to place each element in its correct position in a single pass through the array. This makes it very efficient in terms of complexity, which is O of n, and space complexity, which is O of 1. So, how does it work? It works by dividing the array into cycles and rotating the elements within these cycles to their correct position. Cycle sort places each element in its proper position with minimal writes. Today, we'll walk through the steps of the cycle sort algorithm, explore its implementation, and discuss scenarios where this algorithm shines.
We're examining the time complexity of cycle sort, a widely used sorting algorithm. Breaking down the cycle sort's time complexity are teach experts analyze cycle sorts performance under various scenarios yielding the following results. Best case scenarios. Cycle sort achieves an impressive 0 of n or O of n efficiency when the input data is already sorted. Average case scenario. However, efficiency dips to 0 n squared due to nested loops hindering performances. Worst case scenario. Alarmingly, cycle sort's efficiency further deteriorates to 0 n squared when dealing with reverse sorted inputs. Implication. This finding suggests cycle sort's suitability for small datasets, education purposes, specific use cases where simplicity outweighs speed. However, for large-scale applications, alternative algorithms like radix sort or quick sorts may be more efficient.
Cycle sort works by finding the correct position for each element and placing it directly. For each element, count how many elements are smaller to determine its target position. If it's not already in the correct position, swap it with the element at the target position and continue the cycle for any displaced element. This process is repeatedly for all elements until the array is sorted, minimizing the number of writes. So basically, it means that we're going to we're going to find the correct position of the misplaced 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 data, and we're going to insert it to the correct position. So this algorithm is so easy because all you need to do is to identify the first element, and then you're going to compare the first element to the other elements and finding all the less than value to the first element, and then after finding the less than value of the to the first element is you're going to add by 1, and then the answer of that is the indicator to the correct position of the first element. So for example, if you have the answer is 7, so it means that the first element is going to be to the 7th position. If it is 5, so the first element is inserted to the 5th position. So until it being sorted. So 5, how many numbers here are less than to 5? So 3 less than to 5, 1 is less than to 5, 4 less than to 5. So we have 4 less than number the first element, then we're going to add the 1, so we have the total of 5. So the first element is we're going to insert to the 5th position, so here. So the new value of this is 5. They're going to 2, 3, 1, 4. So as you can see, they're not fully sorted. So we're going to repeat the process. So the first element is 2 is 3 is less than to 2. Now 1 is less than to 2. Yes, so we have 1. Then all these are greater than. So 1 plus 1 is equal to 2. So it means that the number 2 is we're going to put in the second position. So here. So they're going to swap. So 2, 3, 1, 4, 5. Na. Then same process. How many numbers in here are less than to the first element? So 2 is less than to 3, 1 is less than to 3, 4 is greater than 4. So we have 2 less than number on the first element. So 2 plus 1. So we have 3. So it means that the first element is we're going to put to the third position. So 3. So they're going to swap. So 1. So the current value of this, the new value of this is 2, 4, 5. So as you can see, they're sorted. So that is the logic of this cycle sort algorithm.
I am Prince Julaico Bustasa, and I will give you an example of cycle sort in real life. In a car business, there will be a time that a customer asks about what are the lowest to highest car prices we have. Using cycle sort, I will arrange the car based on their prices so that we can guide the customer on their request. Let's assume that these cars are the cars we need to arrange using the cycle sort. The first car has a $4,000. We need to count how many cars are the lower than $4,000. 1, 2, 3. And the $4,000 car will move to the third element. And the next one we need to count will be the $6,000 that lower than it. 1, 2, 3, 4, 5. And we will exchange it to the $1,000. Let's notice what happened. The $4,000 move here, and the $6,000 move here, and the $1,000 move here. And that's the cycle in the name of cycle sort algorithm. Let's try to move the second car. There are only one car that's lower than it, which means it's already at the right place. Let's try the third car. 1, 2, 3, 4. It has 4 cars that lower than it, which means we will move it 4 times. 1, 2, 3, 4, and exchange it to $3,000 car price. So now, we already arranged the cars in order from lowest to highest. The cycle sort method also applicable in some store or market for their products.
Hi everyone, I'm Kusum Kindi Andres, and I'll show you a real-life application of cycle sort by organizing student grades from lowest to highest. We'll break it down step by step so you can understand how this algorithm works in practical scenarios. Here's an example of cycle sort. Sorting student grades are 85, 70, 80, 75, 95, and 90. Step 1. Let's look at 85. Count how many grades are smaller than 85, which are 70, 80, and 75 are smaller. So the correct position of 85 is at index 3. Swap 85 with the grade at index 3, which is 75. The student grade become student grades become 75, 70, 80, 85, 95, and 90. Now step 2. Now look at 75. Count how many grades are smaller than 75. Only 70 is smaller, so the correct position of 75 is at index 1. Swap 75 with the grade at index 1, which is 70. The student grades become 70, 75, 80, 85, 95, and 90. Now check at 75 again. Count how many grades are smaller than 75. Only 70 is smaller. 75 is already in its correct position, so move to the next grade. Look at 80. Count how many grades are smaller than 80, which are 70 and 75 are smaller. The correct position of 80 is at index 2. 80 is already in its correct position, so move to the next grade. Now look at 85. Count how many grades are smaller than 85, which are 70, 75, and 80 are smaller. 85 is already in its correct position, so move to the next grade. Now let's look at 95. Count how many grades are smaller than 95, which are 70, 75, 80, 85, and 90 are smaller. The correct position of 95 is at index 5. Swap 95 with the grade at index 5. The student grade becomes 70, 75, 80, 85, 90.
Cycle sort is in a place and stable sorting algorithm that is particularly useful when sorting arrays containing elements with a small range of values. It was developed by W. D. Jones and published in 1963. The basic idea behind cycle sort is to divide the input array into cycles where each cycle consists of elements that belong to the same position in the sorted output array. The algorithm then performs a series of swaps to place elements in each correct position within each cycle until all cycles are complete and the array is sorted. Here a step-by-step explanation of the cycle sort algorithm. First is start with an sorted array in elements, and second is initialize a variable cycle start to 0, and third step is for each element in array compare it with every other element to its right. If there are any elements that are smaller than the current element, increment cycle start. And the fourth is if cycle start is still 0 after comparing the first element with all other elements, move to the next element and repeat step 3. And fifth element is once a smaller element is found, swap the current element with the first element in each cycles. The cycles is then continue until the current elements return to its original position. And repeat step 3 to 5 until all cycles had been completed. The array is now sorted. One of the advantages of cycle sort is it has low memory footprints, as it sorts in place and does not require additional memory for temporary variables or buffers. However, it can be slow in certain conditions, particularly where the input array has a large range of values. Nonetheless, cycle sorts remains a useful sorting algorithm in a certain context, such as when sorting small array with limited range.